We will be in our books today, but not on this first one. All right. So I heard Zebby would be like, I know what it's going to be.
21.
How do you know that?
No, it's
Oh, debate.
I did 2 more times than 2 plus 1.
It's gonna be 22.
How you did it? Yeah, I did it.
Times, so each pattern is 2 plus 1. It's 2 in plus 1.
But then 21.
I did 21 times 2 plus 1. That's 43.
That's
No, I'm 1 off from that.
Okay. So we talked about this pattern before, where every one of these is made up of 2 pieces, and then we had that 1 spare, right?
Right.
So we noticed our pattern. We built this the other day.
We got 2 of them.
So we got the 2, and then we'd have our 2 times whatever our figure number is, and then we add 1, and we want to know when that equals 43. So we could set this up as an equation. Oh my gosh, look at that. Tying in. Yeah, you were off the pattern.
I was
So,
minusing 1, that's why.
huh?
What happened to 22? I thought it was 22.
That's the answer. We're not there yet. I don't have an answer.
Oh.
That's how we would set up the problem. What would we do to solve it? What would we do to solve this? 2n plus 1 equals 43. Subtract 1 from both sides. So we'd have our 2n is 42. So our n actually equals?
That's why I see.
Yeah.
Which one is?
21.
I was also
Okay.
minusing 1.
Yeah. So it does sometimes help to actually write things down. Shock.
I also want to
And-
go with my answer.
Right.
And just go along with it.
We also need to make sure we're doing our own thinking, okay?
That was my
It
thing.
was a test.
I know. I do that all the time. Okay. So again, we're going to have these kinds of pattern things pop up fairly frequently so we can practice recognizing the patterns, building the equations, playing with the expressions. But I know we've seen this pattern before. I'm not sure if you remember it, but it's been because it's only been a couple of days. All right. So we are going to be in our books today. I know yesterday everybody got their books out and I never touched them. I know. I'm horribly cruel.
Be back in the book.
Back in the book. I know. We're going to be on page 34. And in fact, I think just page 34. And there are 3 questions on page 34. Just 3. So page 34, where we're going to be. $34. I usually have it written up here, but I know the contrast is not great on this one. Nope. There. That's a little bit clearer. The contrast is not great with the black text on the pink box. Okay. So read through this story for number 1. So our first job on a question like this is to figure out what are we trying to find? Our first job on a question like this is to figure out what we're trying to find. What is it we don't know that we want to know?
Number of songs for each girl.
Yeah. The big old clue for that is in our question. How many songs did each girl download? Helps if I actually get all the way to the end of the word. There we go. So I want to know how many songs Jane downloaded. So we want to know a number for Jane. We want to know a number for Tracy. And we want to know a number for Inez. If we have some things that we don't know, and we're trying to write like equations and stuff, what might we use? A variable. And in fact, I have 3 things I don't know, so how many variables are we going to need? 3. What do we want to use as our variables? We can absolutely do a T. T for Tracy might make sense. What else do you want to use? J for Jane. And I. Not rocking the boat. It's like, don't shuffle them. Don't put T for Inez and J for Tracy. That would be hard. That's absolutely fine. We can use whatever variables you want. So what we're going to do is we're going to try and write an equation or maybe a few equations with this situation. So we're going to kind of work this one together, probably kind of slowly. So if I know that all 3 girls download a total of 36 songs, I'm going to stop at 36 songs. How could I say that the 3 of them combined downloaded 36 songs?
G plus T plus I equals 36.
Yeah. Jane downloaded some songs, Tracy downloaded some songs, and Inez downloaded some songs. So we could take Jane's songs plus Tracy's songs plus Inez's songs, and we know that's going to total up to 36. Yes, back in the day, we did have to count how many individual songs we downloaded because each song cost money. If everyone downloaded the same number of songs, we could do that. So that would be everyone having the exact same number of songs. Unfortunately, they didn't all download the exact same number of songs. Otherwise, we could divide by 3 and it would be good to go. So it's an excellent idea, but it's not going to quite get us where we need to be. So we're going to need to use some more information in here. What else do we see in here that might help us?
Jane downloaded twice as many as Inez.
Jane downloaded twice as many as Inez. So can we use this to write an equation? What could we do there? I heard us have an idea. I just couldn't hear you. So we know that some sort of relation between Jane and Inez, right? Well, we know that Jane has twice as many as Inez, right? So it's going to be some sort of equals relationship between them. So somebody's going to need 2. Like, yeah. However many Inez downloaded. Let's pretend Inez downloaded 2 songs. How many would Jane download? 4, because Jane got twice as many as Inez. If Inez downloaded 3 songs, how many would Jane get? If Inez downloaded 3 songs, how many would Jane have downloaded? 6. Because whatever Inez has, we times by 2 to get what Jane has. So Jane is the same thing as 2I. What was that? Yes, let me write it fast. Okay, so look through there for another sentence that we might be able to work with. And Kendall. Hang on, right fast. There's not a chance we're going to be able to read that question when we go up there. Alright, so I've heard some of us notice that Tracy was being a little kooky dukes. She was being a little greedy. Tracy wanted to have the most. She was desperate to win. I'm sure none of us know somebody like that. Tracy wanted to have the most, so she downloaded 1 more song than Jane did. If Tracy downloaded 1 more song than Jane, what can we do to write that? T is however many songs Jane downloaded plus 1. So now I know some things about Jane. I know some things about Inez. I know some things about Tracy. And I know some things about all of them combined together. So what could I do with this piece and this piece and this piece to help us figure out how many songs we had?
Plug them into the equation.
Think back in our algebra days. Oh snap, I'm gonna make you think about math stuff. Shock, right? I know. Horrified.
Oh, did you see my answer?
No, I did not. I'm not looking. So I could take this piece here. I know that J is the same as 2I. I have J down here. I could substitute that in here. So I could rewrite this as 2I instead of that J. And I know that T equals J plus 1, so I could substitute that in here. J plus 1. Oh, that's an I, not a T. Sorry. Plus I. So that's better, but not quite all the way there yet. I mean, we can combine this together and make it look less gross. Because I have 2 I's plus J plus 1 plus I. What can I do to simplify this line without changing anything else? If I have 2 iguanas plus a jackalope plus $1 plus another iguana.
Combine like terms.
We've got some like terms in here.
Or
Or we can realize I've got another J in here and oh shoot, I don't want to have J's. I want to have just one letter. I still have J's, so I'm not necessarily going to subtract. Look back up at the top, look at blue. I know about J again. So I went through a substitution here, but it's still going to give me my J. I can still take this J and substitute it. So we have 2I here, and everything else is going to drop down. So I've got 2I plus 2I plus 1 plus I equals 36. And that looks like a mess. It does. How many I's do we have in that row?
4.
I have heard 3, 4, and 5.
6.
Okay,
5.
now 6 too. So I have 2I and 2I plus 1 plus I.
Yeah, that's 6.
So there's 2, 4, 5.
5.
1. I thought it was a 9.
Oh yeah, that's why I did them as capitalized. So I have 2 iguanas in a box, and then I have another box with 2 iguanas, and I have $1, and then I have a loose iguana. I have 5 total iguanas. So we have, combining our like terms here, all we have is 5I plus 1 equals 36. And that's a lot less messy. Super lot less messy. So what can I do here? Subtract 1. So we have 5I is 35. So what does I equal? I equals 7. Woo! We did that. We got that all for a 7, right? We're done, right?
nope.
Why not?
We gotta find J and T.
I was asked how many songs did each girl download. All I know is how many Inez downloaded. Inez downloaded 7. How many did Jane download? Twice as many. So 14. How do we know?
Add 1.
Yeah, because remember Tracy was kind of our kooky duke. She needed to win person. She had to have the most, so she got 1 more than Jane. So Jane had 14, so Tracy had 15.
14 fully coded.
And when you guys did algebra 2, we spent a good 3 or 4 days learning how to do problems like this that had X, Y, and Z. 3 variable systems. Y'all just did that with your gut. We just finished it. This is technically a 3 variable system of equations. We spent at least 2 to 3 days in Algebra 2 on this. And you guys just instinctively went through it because it had a context. Okay? So I want you to look at these other 2. I want you to try them. Number 3 is very similar to the one we just did. Number 2 is a bit of a different shift. So I want you to look at them. Take like 5-10 minutes. We'll go through them. But I might hand somebody an iPad to do one. I just have you do it. Okay? So, I want you to try numbers 2 and 3 on this page. See what you got. Show me what you got. Love that.
Jane did twice as many as Tracy did one.
Mm-hmm.
So, there you go. That hurts so much. Not that she's okay. You need help?
It's okay, you come for the next one. I'm happy to help. What I'm here for. Like, literally my job, my dude.
Trying to take it.
Figure out what things can. Okay, so, look at the very top. See how I have the blue one that says J2I? That came from our Jane downloaded twice a day. So whatever Jane has, it is twice a day. So we're gonna download Jane by, right? The pink one, that comes from our, Tracy wanted to have the most. So she got 1 more digit. So whatever Jane has, if Jane got 7, Tracy got 8. Jane got 9. So she got 1. So whatever Jane had plus 1 is what Tracy got. So the pink one is the top. So when we looked at this guy, where we had however many like Jane and Tracy and Ed, they got 36 on, right? Well, but I can solve it when it's got 3 letters. But that doesn't work. But I know Jane had twice an S. I know Tracy had whatever Jane had plus 1. And so that gives us another J here. So now I gotta use my J had plus the S again. That's over there. 2I is 2I plus 1. There's a plus 1 there. Yeah. And then plus the I, right? So we have 1, 2, 3, 4, 5 I's and a 1. Because, yeah, because Tracy was petty and wanted to have 1 more than everybody else. That's wrong. I'm sure none of us know someone like that.
Me.
Like, no, nobody that,
Maybe
you
you
know,
might get
has
it
to
staring
be.
at the boy.
That boy.
It's me.
Oh, right there.
Me, I have to win.
So it's not really. Feels better.
What's that? Okay. Problem time. There's lots of ways to do these. I can show you the one that I will do it.
So, already, I don't know.
Mhm.
That's exactly.
Remember, I knew it. Because I did the same thing.
You got one.
That's one of the ways through it. Absolutely one part. Yeah, there's lots of ways through it. Yeah.
But this is the equation.
Mhm. It starts with 4,800, we're taking away $300 from us. And we wanna know when it gets added, it's exactly the equation happens. Okay?
The devil.
Oh, he was.
Oh. Looking for water.
You're not listening.
Bless you. I'm coming. And then I'm coming to you. And Sophia, then Gabby, I promise. Get here. Mm-hmm. Mm-hmm. Gorgeous. Mm-hmm. Mm-hmm.
Y'all think, I'm already done. You talk the first one, everybody get it done.
Yeah, you can do that. That's a guess and check way. Absolutely.
I'm talking to you. Yeah, you're talking to him. You're talking to you.
Mm-hmm.
You're talking to me.
So you could absolutely do it that way. You can also set yourself as an equation to solve it because we want to know when this leaf. Man, you did a beautiful job. Fantastic. Good job. Gorgeous. We want to know when this thing equals what. Mm-hmm. So put equals,
Francis, what are you
and
talking
then
like
put
this?
that thing. Mm-hmm. That is also valid. Okay, by doing a plugging in a system. What if it had been 50 months though? I would have taken it. Okay, so on little ones like this, that absolutely works. Okay. Mm-hmm. You can. If you want to make it so that this is a negative, you could add our 300x. It would just wind up like plopping over here next to it.
What does that mean?
That's totally fine. And then we would need to subtract this guy. So you can absolutely go that way. Go for it. Give it a shot. You got this. This here. Got my next here. Show me what you did. Okay.
You see this?
Uh-huh.
300.
What you want, my love?
Okay. Yeah.
But this is not.
Mhm.
You have to do 300 times to get the answer. And then take the answer off that one.
What it looks like you did to me is you did our total that we started with, and you figured out that it was 300 each month. So you're like, well, I definitely see that 10 of them are coming out because 3,000 is 10 of them. Mm-hmm. Yep.
I won't be different because I
And you Are we asking about days? Months. Okay, so you did this subtraction. So this one was 10, right?
Takes 10 months.
To get it down to our 1,800, right? So you subtracted 10 months, get from 4,800. How many more months did you need to get down to 1,500? How many more 300 out of the 1,800? Not entirely sure I subtracted that. Okay.
You take 4,800.
Yeah. Yeah.
See?
So where did the 3,300 come?
11 times.
I mean, you did fine. Like you're accidentally yourself all the way around here. Okay, you were right at it. So we wanted to know when our 4,800 minus something was 1,500, right? So now all you gotta figure out is what you did to get that. Because you did a thing, the 3,300. Because that's the answer. If 4,800 minus this, we wanted it to equal this. So now you gotta figure out, you accidentally lead yourself into the right answer. Okay, see how we get from our 300 to this 30. You did right here. This is the money line right there. Okay? That is this piece right here. Okay, I'm grabbing the door. I asked you, how did you next?
Or you can just do what
What's up? Why do you make me walk all the way over here, Dad. Dad, my glasses are over here, dude. Then you walk over and walk back. Come on, man. I know I need to get my steps in, but get my steps in. Come on, man. Yes, dear. George.
Purple versus green.
Excellent. Fantastic.
No, bro, shut up.
It's always been red versus green.
It still is good. I haven't looked at it yet, but it looks good. The process looks great. All right, so I feel like a lot of us have started to get this check one ready. Gorgeous. Fantastic. I do not remember the episode, but it looks like you're setting it. Okay. Yes, dear.
So I got that.
Mm-hmm.
I don't know what to do after.
Why are we dividing by 30?
Because I thought it was like the days.
So this is what we wound up paying, right?
It was supposed to be.
Well, the 3,300, that's what we're figuring out right here, right?
You were horrible.
We paying how much each month? So how many payments to make this number here? So we can take our 3,300 and divide it by 300 to figure out how many months we took our payment. Okay, so I'm gonna start looking at number 2 up here. I feel like most of us have, at the very least, got it started in a way that is exactly what I would do. Most of us, at the very least, figured out that we're starting with 4,800. And we are spending or removing, so subtracting 300 every month. Do we know how many months it is?
11.
At this point, we do not, so we're going to use an X, but yes, it does wind up being 11.
Oh, I put the X in the wrong spot.
That's okay. It's 300 per month, each month. That means that this piece winds up with a variable here, each month, per month. And we want to know when this expression equals what? The 1,500 or 1,500. From here, I've seen about 6 different pathways through, all of which were right. There are lots of ways through this. You could add the 300x and subtract the 1,500 to make sure we don't have any negatives. We could subtract the 4,800 and then divide. We could guess and check when our x winds up being 11. That works. However, if we'd given you something that was going to take 50 months or 80 months or 87 months, that would have been harder to spot and harder to keep track of. So be careful relying on guess and check too much. So our x should have been 11. There's lots of different ways to solve this. I think the most time effective one would be to subtract our 4,800, have minus 300x equals negative 3,300. Divide by negative 300 on both sides, and we get 11. That one takes the fewest number of steps, but it is by far not the only option. It's the fewest number of steps, but that is not always the way our brain goes through it. Our brain does not always pick the easiest path, and that's okay. Follow your brain's path. Okay, and I know a lot of us started to get number 3 set up. What do we have so far for number 3?
That's the answer.
I'm sure you do. So Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. Okay. So how can we use those 3 sentences to help us figure out how old they are? Yeah. This is just like that first one with the iPod. We were taking our Justin plus Peyton plus Matt is 39.
Divide that by 30.
If they were I was like, if they were the exact same age, that would work, and this would not be a hard problem. So what else can we do? So we use the pink one. P equals J minus 3. Absolutely valid. You could also put P plus 3 is J. P plus 3 equals J. So you could build that in two different ways. How about for Matt? Matt is 4 times Peyton's age. 4 times as old as Peyton. I know I'm right on the edge there. Okay. And then you treat it just like we did the first one. We're going to do some substitution. I know what P stands for. P is J minus 3. J is down here. And we know what Matt is. Matt is 4P. So that helps, but we're not quite all the way to the point where I can do something with this yet, because I have another P. Substitute again. So we can make this be 4 times all of the J minus 3. So be careful. It's 4 sets of that J minus 3. We good? Squirrely is what they doing. So what did we get for our answers? How old is Peyton? What's that? I was like, I get a feeling I'm gonna come back here and hang with my friends for a little bit. I'm gonna come back here and hang with my friends for a little bit because we're feeling a little squirrely back here. We're feeling a little squirrely back here. What's up, friends? What did we get for Peyton? 6. So that means how old is Justin? Justin is 9. And how old's Matt? 24. So that would be called, you know, dad and, well, probably not dad, probably uncle and kids.
Why could I not be the dad?
He'd be 13.
Okay.
I'm not saying it's impossible, but let's just go with optimism. If Matt's the dad, he was 13. Let's go with uncle.
Or he adopted
No,
them.
wait, no, he
He could have adopted them.
Okay, 15. Still optimism. Let's go with uncle.
Or he adopted them.
Stepdad. Okay, at 24, if we are adopting, we have some pretty serious money. Stepdad.
He could have adopted.
That's a lot of money for 24. Adoption is very expensive.
He was a foster parent.
Also expensive, and
Or it
single
could be
man at
his
24
natural
being
son.
approved as a foster is probably not likely. Not saying impossible. I'm just going with optimism. Ideally.
He's too rich.
We support that. Okay. Rich absolutely rich families, please foster all the children. If you can afford it, have them all. Take the ones with the money.
But then we'll have all
If your bank account has more than 1 comma in it, yes, you take all the children. Okay.
But then that would be a problem.
Oh, that's where you think orphanage just came from. All right, so that's it for today.
Boo, I'm yay.
I'm like, I can give you more. So we do
Let's not. No, let's not.
the first homework of the chapter.
Oh my.
Breathe. Oh my gosh, y'all. So the first homework of the chapter, it is up on Canvas. All of our homeworks are on Canvas. It's the only one I'm giving you this week.
Yay. Is that gonna be like that every single week?
You should
It is, I think, at most 2 a week. Like it's, and they're on Canvas.
Ooh, so it's not getting them homework every single night.
No, I'm not gonna give you homework. You had 4 in the last chapter, and it took us almost a month. I think in this chapter there's 4, and they're all posted, run out, up on Canvas. There's not surprise homework.
Straightforward and transparent.
Straightforward. I am a firm believer in open, honest communication.
It's a trap.
Okay, it is not a trap.
It's a trap.
This is a senior level elective course. It's not a trap.
It's a trap.
It's niceness.
I ain't never seen this college.
It's niceness.